Hi everyone, welcome to my YouTube channel Take Data Engineer. So today we will see data partitioning in pyspark. Okay. Why this is important and what are the data partitioning and what are the method to do that. Okay. So before going to data partitioning, we will see what is partitions first. Okay. So partition is nothing but a chunk of data in pyspark. Okay, so suppose you have a table and some name. Okay, some column name. So if you wanted to partitions your data based on column name, you will give your column as a partitions by. Then your data got partitions in the different block. Okay, so partition is nothing but a partition is a chunk of data. So in pyspark, data is divided into multiple partitions which are processed in parallel across the cluster. So different cluster we will do the partitioning and then we'll do the data processing. So what is data partitioning basically? So data partitioning refers to the way data is divided into smaller chunks or partitions and that can be processed across the distributed node. Okay, so we have different nodes, worker node, so where you can say data got partitions and it will distributed to all the cluster node for parallel processing. So why we are doing partitioning? Because so processing one huge file will take much time. So if you do the data partitioning and if you wanted to you can say do parallel processing, it will be optimized for doing our partitioning and all. So that's why we are doing. And for load balancing purpose also, because if we will distribute if we will do the partitioning and if partition data will get processed, that would be more balanced compared to the huge file. Okay, and sometimes we require to store the data in the partitions way, not with the huge file. So that there we also for writing the data also data partitioning required. So partitioning is nothing but based on certain key or default or based on like coalesce on or repartitions, we are partitioning the data based on certain patterns. Okay, so that is called data partitioning. And why this is required? The data partitioning is required because we wanted to optimize our solutions. Okay, and for load balancing, for faster processing, for optimized parallelism, we wanted to achieve all these things. That's why we are doing data processing. Okay, so we have already seen that what is partitions is nothing but chunk of data. So suppose we have 1 GB of file and then we have taken 250 of 1 MB of 250 MB and we have kept like a 4 partitions so that it will go and process with the 4 nodes. So that would be very easier. So if one partitions with the same configuration, if do that processing, it will take more time. Instead of we will split into 4 partitions and distribute to the different worker nodes, so it will take even 1/4 of the time. And even our resource also have balanced workload, so that will also one of the benefits for that. Okay, so partitioning matter because of parallel processing. So partitions allow the Spark to process data in parallel, which can speed up our computation significantly. Okay, and then other would be the load balancing. So proper partitioning help in distributing the data, distributing the load evenly across the nodes in the cluster. So if you will do the partitioning, every node have the proper balancing. Okay, then resource management. So if you do the partitioning, so it ensure that your each resource will be utilized efficiently. Okay, instead of getting one of the resources load. Okay, so we will see key concept basically. Okay, we will see key concept, or you can say partitioning strategy. So there are three types of strategy. One has default partitioning, other is the custom partitioning, and third is the repartitioning or coalesce. Okay, so what is called default partitioning? So default partitioning is nothing but a Spark. If you will submit your job, then what will happen? Spark eventually partition data based on the data source and the cluster configuration. So whatever the data source you are passing and whatever the configuration you have passed in your job, it will do the partitioning based on that. So that is called default partitioning. Okay, so like when reading a data from a file system, Spark might create a partitions per file or per block of data, which whatever the configuration you have given, it will do that. So that is called default partitioning. So let us see a code here. I have created a Spark session, and then I have created the data, and then I have checked here like df.rdd.get partitions number. So it will basically throw what are the how many partitions are there. So get num partition method will give, get num partitions method will give like how many partitions are there for that, and we can display that. Okay, so reading the data file, what we have to do, we have created the data frame, and then we have checked okay how many data frames are there, so that way we can inspect our partitions. Then second will be the custom partitioning. So in custom partitioning you can control the number of partitions and partitioning logic using method provided by the pyspark. So custom partitioning is like if you wanted to do your customization partitioning, you can do that. So there you can use repartitioning. Okay, repartitioning. So repartitioning, what basically do, repartitioning is basically used for increasing or decreasing the number of partition used for used. Okay, so we have to do df dot repartition, so we will see that also. So in repartitioning, what we have done, we have created a Spark session, then we have created a session, and then I have created the data I multiplied by 2 for I in range 1 to 1001. So for this range we will take the data, and then df dot partitions, so partition data frame equals to df dot repartition 10. So what we are doing, we for entire whole data we have taken a 10 partitions, then I in that inspection of the partitioning in num partitions, df dot partitions by to get num partitions. So this basically show that okay how many partitions are there, so it will throw the number as a 10. Okay, then third option is, so we have for custom partitioning we have method called df dot repartitions. Okay, so repartitions will do, and then third option is the collage. Collage is one of the method. So collage, so repartitions basically used for increasing or decreasing the number of partitions. Suppose you have 10 partitions, you wanted to make it 20, you will do that. If you have 20 partitions, if you wanted to make it 10, you can do that by use of repartitioning. But collage is opposite of that. We can't say opposite, but they have only one feature. With the help of collage you can only reduce the number of partitioning. Okay, their method is df dot collage. Okay, so we same example I have taken. I have created the Spark system, taken the data frame from range 1 to 1001, then I have used df dot collage. So basically you wanted to decrease, so I have taken 5 partitions and I have taken as a partitions and partitions by. Then third option is with the help of partitions by column, or you can say custom partitioning. So custom partitioning, we required partitions by, so by this method also, based on certain column, if you wanted to partitions your data based on column. Okay, when writing data you can partitions based on a column. So when you wanted any column like partitions by any column or one or more two column, you can use this partitions by. Okay, I created the data frame, and what I have done here, I have used the function like df dot write dot partitions by category. So we have two column id and category, but I wanted to write the data based on category, that format equals to parvet and that shape this one. So I wanted to write the file in file for parquet file format, but as a partitions by category, so I'll use the method called df dot partitions by. So we have in custom partitioning we have three I can say three functions, pyspark functions. One is the repartition, second is the collage. So repartition basically used for increasing or decreasing the partitions, second is the collage, and third is the partitions by. Partitions by mostly used when you wanted to partitions your data based on certain column, so you can do that. Okay, so default so partitioning basically Spark automatically do. Repartitions is used to increase or decrease the number of partitions. Collage is basically used to decrease the number of partitions. So call is more efficient than repartitions when reducing the number of partitions. And the fourth one is the custom partitioning. Custom partitioning is either custom partitioning, or you can say partitions by column. Both are same. So by that method, if you wanted to retrieve data, certain data based on certain column, you can do that. Okay. So this is the four way to do the partitioning. So this partitioning require help us to do the data skewness and balancing also. To handle the skew data, we used to do, we might need to use technique like salting or custom partitioning. So if we have data skewed data in our, why we are doing partitioning, basically if the questions comes, or if this comes into your mind, then if we have the data skewness or there is no balanced data, then we are using method like salting, or using the custom partitioning to do that. And to view the, if suppose if you have data frame, and if you wanted to view that, okay, how many partitions are there, we will use the pyspark method called rdd.get num partitions. So get num partitions basically used to take that, okay, how many partitions are there. Okay. So and we have to think, we have to just take care these things while doing the partitioning. Like we have to match the partition size with the task size. Why? Because if partitions that are neither too small or not too large, so if this is too small, then we it will increase the overhead. If it is too large, which can leads to the long running time, so we have to take care this match partitioning size with our task. And we have to avoid the too many tasks also, too many partitions also, because having too many partitions can leads to the excessive overhead and a decreased performance. So we have to avoid these two things also. Okay. Okay, that's it about that partitioning. Thank you, thanks for watching.